In the previous section, we looked at how we can use the definitions of right triangles to be able to evaluate the six trig functions. We're going to do the same thing in this video, except we're going to go ahead and take a look at special angles, at special triangles as well, and namely the 45, 45, 90, 30, 60, 90. All right, so in this example, we're just going to find the six trigonometric functions at 45 degrees. And of course, we're going to rationalize. Let's take a look at 45, okay? And one thing we have to remember is the definition, okay? So remember, we have our SOHCAHTOA, some old hog, came around here and took our apples, okay? And remember, that tells us the relationship between sine, cosine, and tangent, okay? So our sine function is going to be opposite over hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So if I was to find the sine of 45, I'd notice first of all that the hypotenuse is going to be opposite the right angle. Opposite of 45 degrees is going to be 1. Okay, so this is our opposite, and then adjacent to 45 is 1. Okay, and by the way, it doesn't matter which of these 45 degrees you pick, you're still going to get the same relationship. All right, I just picked the one in the upper left-hand corner. Okay, so remember, adjacent is the one that's touching 45, and then opposite is the one that's going to not touch 45 degrees, but is not the hypotenuse. All right, so at this point, our sine function, so the sine of 45 degrees is going to be the opposite over the hypotenuse, right? And that's going to be 1 over the square root of 2. And then we can rationalize this by multiplying by root 2 over root 2. And that should give us root 2 over 2. In a similar vein, we're going to find the cosine of 45 degrees. Cosine is adjacent over hypotenuse, right? So that's going to be 1 over root 2 as well, which we already know to be root 2 over 2. Finally, the tangent of 45 degrees, that's going to be the opposite over the adjacent. So that's 1 over 1. And by multivariable calculus measures, 1 divided by 1 is 1. Now we can just take the reciprocal to find the cosecant, to find the secant, and then finally to find the tangent or the cotangent function at 45 degrees, right? And so the reciprocal of 1 over root 2 is going to be root 2 over 1, which is the square root of 2. The reciprocal of the cosine function at 45 is going to be root 2 over 1 as well, which is going to be square root of 2. And then finally, the reciprocal of 1 over 1 is 1 over 1, which is 1. Right? The sooner we can memorize these values, the better for us, okay? Because these are going to come up very consistently in trigonometry. And for those of you that are going on to calculus, Calc 2, studying physics and engineering, this is going to be a vital component of memorization. Another way that we can utilize right triangles is looking at the 30, 60, 90 right triangle. And so we want to find the six trig functions at 60 degrees, okay? So let's take a look at 60. And we know the side that's going to be opposite of the right angle is going to be the hypotenuse, which is 2. And then adjacent is going to be 1. And then finally, the side that's going to be opposite is going to be the square root of 3. Okay, so remember, opposite is the side that's not touching, but is not the hypotenuse, right? And then opposite the right triangle or the right angle in the triangle is going to be the hypotenuse. Okay, so the sine of 60 degrees, which is going to be the opposite over the hypotenuse, so is going to be equal to root 3 over 2. Okay, so that's pretty easy. The cosine of 60 degrees, which is the adjacent over the hypotenuse, that's going to be equal to 1 over 2, otherwise known as a half. And then finally, the tangent of 60 degrees is going to be opposite over adjacent, which in this case is going to be root 3 over 1. Or some call that root 3. All right, so those are going to be our three trigonometric functions. Once we have those three basics, we can take the reciprocals. Okay, so the cosecant at 60 degrees is going to be root 2 over 3. All right, and then we're going to do some rationalization. Okay, so we're going to multiply that, or it's going to be, excuse me, 2 over root 3. Okay, sorry about that. So that's going to be 2 over the square root of 3. We're going to have to do some rationalization here by multiplying by root 3 over root 3, right? And so root 3 over root 3. And so that's going to be equal to our 2 roots of 3 divided by 3. And then the secant of 60 might be the easiest of these functions for the reciprocals. That's going to be the reciprocal of 1/2, which is 2 over 1, which is 2. Finally, the cotangent of 60, that's going to be the reciprocal of root 3 over 1. So that's going to be 1 over root 3. We're going to rationalize that by multiplying by root 3 over root 3. And that should work out to be root 3 divided by 3 when we multiply through. So the 1 times the root 3 is root 3. Root 3 times root 3 is 3. All right. Again, these should be values that we memorize. Okay. If we memorize the first 3 of these, then the rest of them will be pretty easy. Okay. Now, last thing we're going to do in this video is we're going to go ahead and find the 6 trigonometric functions at 30 degrees. All right. And then we're going to see that there is a relationship between the angles at 60 and the angles at 30. Okay. So going through, we look at this, and certainly we know that 2 is still the hypotenuse. Opposite of 30, the side that's not touching 30 is 1. And then adjacent to 30 is going to be root 3. Right? And so that means that if we go through, we have the sine of 30 degrees is going to be, again, opposite over hypotenuse. The opposite is 1. The hypotenuse is going to be 2. So this is going to be 1/2. The cosine of 30 degrees, adjacent over hypotenuse, which is going to be root 3 over 2. And then finally, the tangent at 30 degrees, which is going to be the opposite over the adjacent. Okay, opposite is 1, adjacent is root 3, so this is 1 over root 3. We just rationalized 1 over root 3 in the previous example, so that's going to be root 3 over 3. Right? Now, we could just go ahead and take the reciprocals of each of those, and that's going to help us to be able to find the other functions. So the cosecant of 30 is going to be 2 over 1, which is 2. Okay, so just the reciprocal of 1/2. The secant at 30, that's going to be, excuse me, that's going to be 2 over root 3. And we know 2 over root 3 is just going to be 2 roots of 3 over 3. We just rationalized it. Finally, the tangent or the cotangent at 30 degrees is going to be root 3 over 1, which is the square root of 3. Okay. All right. Now, before we conclude this video, I want you to notice that there is a relationship between the sine of 30 and the cosine of 60. Okay. So take a look at this. The sine of 30 degrees is 1/2. The cosine of 60 degrees is also 1/2. Okay. Also notice that if I were to take a look at the cosine of 30 degrees, that's the same thing as the sine of 60 degrees. Okay, so we see that relationship. And the same exists with the tangent and the cotangent. Okay, so if I was to take a look at the tangent of 30 degrees, which is root 3 over 3, that's the same thing as the cotangent of 60 degrees. Right? And also notice that the cotangent of 30 is the same as the tangent of 60. So we have this cotangent of 30 and the tangent of 60 are both root 3. And then not surprisingly, there's a relationship between the cosecant of 60, which is 2 roots of 3 over 3, and then the secant of 30, which is 2 roots of 3 over 3. And then finally, not shockingly, is that if you have the secant of 60, which is 2, that has the exact same value as the cosecant of 30, okay? Now, notice that these angles, 60, secant of 60, and 30, they add up to 90, okay? Those are complementary angles, okay? We're going to see that right triangle trigonometry has these complementary angles that are co-functions of one another, okay? That's going to be a little bit later in this section, okay? But just kind of planting that idea in your head. But for right now, what I want you guys to do is just to be able to find your 6 trigonometric functions of any right triangle given that angle.